Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Our group, which consists of Muhammad Isra, Nazia Nuha, Aiman Balkis, Mariam Jamila, and Nick Nurafika, will be presenting about precedent studies and case studies about commercial fishes. First of all, commercial fishes are known as fishes that are consumed by people every day. However, overconsumption, climate change, and pollution leads to the decreasing amount of fishes. Therefore, to overcome this issue, rehabilitation and conservation is required for commercial fishes to control its population. Some examples of protected commercial marine fishes are such as the mangrove red snapper, one spot snapper, the barramundi, honeycomb stingray, and pale-edged stingray.
Bismillahirrahmanirrahim. So first we start off with the first precedent study, which is the prime foundation of the rehabilitation and conservation of marine animals in Barcelona, Spain. So the building is actually a refurbished building that is a former golf course and it incorporates with existing constructions. And the main activities of this building is clinic and rescue. It also collaborates conservation, investigation, and innovation within one site. So next we move on to the analysis of the building, which is the building consists of a view towards the nature that allows and maximizes the natural lighting and natural ventilation into the building. And also the building incorporates a view towards the nature that limits public contacts. Next we move on to the rehabilitation and clinic center, which can be found within the building. This will aid the staffs to examine and feed the animals rehabilitated there. Also, if we observe from the tank at the center, there's a side view glass that allows staff to observe animals from the side of the tank instead of using the platform. And the tank platform actually is the staffs to examine and feed the animals rehabilitated there. So if we look at the bigger scale of the site itself, so the building actually separates into three different parts, which is the post-mortem studies building, the administration and educational building, and also the clinical building. So if you look closer at the clinic building, it's actually a clinic area and the leftist part of the building, the outer area in the middle part of the building, and also the tank area. And also, as you can see, the tank area for the dolphin and the turtle are separated into two different parts because they are from different species. So as you can see from the side plan, on the left part of this diagram, the public entrance is actually on the southwest part of the map, and also there's the private entrance from the back of the clinic building. Special organization of this building that you can see over here at the floor plan is linear organization. Also, the rehabilitation center is placed at away from the city center. Okay, so next we move on to the second precedent study, which is the Antalya Aquarium in Antalya, Turkey. So as you can see from the facade, the concept of this building uses a wave-like shape on the facade. Also, the main design decision is to be vanishing in the silhouette and harmonize the building shape from the topography, which will be seen in the elevation later. The shaded public area is to beware from the sun and profit from the wind from the ground level. So we move on to the analysis. So the first analysis that we get from this building is the building provides good view from the rooftop that overlooks to the city of Antalya and the Konyaaltı beach. Also, if you can see from the front part and the rear part of the building actually provides an adequate parking spots for all visitors. Since the building is placed on the topographic slope, so the rear part is actually higher, so they can access directly to the rooftop. So most spots inside of this building actually provides a skylight to allow natural lighting into the building. So for the next insight that we get from this building is that from the plan, you can see the spatial organization is clustered, and also the rooms are separated according to the definition of the marine creatures. As you can see on this part of this building, which is on the first floor, there is no room that provides for animals that adapt with the cold climate. Also, as you can see from the southeast elevation, the building is seen to respond or harmony with the slope shape. Also, some parts of this building, which is the wave-like shape, it actually incorporates from the facade and become the building structure. So based on both of this building, the synthesis that we derive from it is the building that is about to be designed can use a cantilever and panels as a shading device, and also using low thermal mass materials to decrease the heat penetration is one of these ideas. So from the entire diagram, as you can see, it uses a stilts on the lower part of the building. So we can implement a similar with the Malay traditional houses that uses stilts to catch wind of higher velocity into the building. Also, an idea is to open parts of the building that faces the prevailing wind to allow natural ventilation into the room decreases the cross ventilation. Another idea is to provide tank with the environment that the fish can adapt, which is based on the temperature, the surrounding, and also the type of the salinity of the water itself.
The third precedent study is the Blue Planet Aquarium located at a shoreline in Kastrup, Denmark. Built by local Danish architects 3XN that takes up to 10,000 square meters of area and was established in 2015. The concept of this building is inspired by the shape of water, which is reminiscent to a whirlpool. The exterior is cladded with aluminium shingles to reflect the ocean nearby, and the main structure material used in this building is steel. The spatial organization of this building is radial because it consists of 5 separate wings that converge towards a center to create a whirlpool shape. Each wing consists of different rooms and spaces. The entrance and arrival hall is located in the first wing that also has the offices and admin. The third wing is where the education and public facilities are located. Meanwhile, the second, fourth, and fifth wing accommodates the exhibitions and aquariums, and these spaces are connected by a gallery in the center of the building. This building has a few sustainable approaches, such as having rainwater catchment along the curvilinear roof for rainwater harvesting. For ventilation and cooling, this building uses seawater cooling from the nearby ocean. And efficient lighting is also applied by using natural daylight and motion sensor LED lights in the building. For the synthesis of the third precedent study, the roof of the building can be utilized to apply catchments for rainwater harvesting. In addition, for the space planning, the spaces within the building can be separated according to their specific functions, and a centrifugal space can be applied to provide easy navigation for the users of the building.
Considering the location of a site, the most suitable movable structure would be the roof. A retractable roof is a system designed to roll back the roof on track to create an open outdoor space. It offers an open air feeling besides providing full view of the scenery outdoor. It used mostly in every building, for example residences, restaurants, swim centers, and facilities that provide an open air experience at a push of a button. There are 3 types of retractable roof. The first one is PVC retractable roof. It can resist the heat and absorb UV rays, but also still allow 80% of the light to pass through it. It is 100% waterproof. It is easy to clean just by using soapy water, especially to clean the mold. And LED lighting could be installed to make the interior more interesting, especially at night. It can resist up to 150 km/h wind and can retract if it gets too fast. It is said that the price is 86 ringgit per square feet. The next one is metal retractable roof. It uses louver system and provides slanted shade. Louvers can change position depending on the sun direction. It can be controlled with a remote, and during the rain it has a sensor and it can close on its own. The louvers will close completely and the water will run through the internal gutter system provided. It is said that the price is 84 ringgit per square feet. Last but not least, fabric retractable roof. Fabric retractable roof is made by a very high quality fabric which makes it waterproof and also mold proof. Hence, the maintenance cost will be lower. It is designed for long span building and it has high tensile strength. It can also withstand rain, wind, and the sun, and it uses modular structure. It is said that the price is 101 ringgit per square feet. The synthesis of second case study, which is retractable roof. The most suitable roof would be PVC retractable roof. This is because it is long lasting, it is lightweight, and it blocks the sun completely. It has reasonable price and also high tensile strength.
LED illuminated building facades can be used to express message, transmit feelings, and generate interest. It is also important to add value to contemporary lighting solutions for building facades, showing a building off to its potential while offering a positive corporate picture. Facade lighting can be used to enhance architectural appeal and building aesthetic, whilst reinforcing the overriding architectural intent. Additionally, facade LED lighting can be used to transform a building's facade into interactive media display which captivates and enthralls. LED stands for light emitting diode and a perfect lighting technology for facade display because of energy-saving light. A single LED includes light, bracket, and connectors, and for some cases it has steel wire. For the one using birch, it contains RGW LED strip, which is known as red, green, blue, and white, which gives more options for color light. Essentially, the efficiency of these strips is higher as the heat dispersed from the LED pins to the seat cooper. The higher the area of cooper, the higher the efficiency. How to install LED on facade building? First, connect steel wire tightener, U-type lock, and steel wire to mesh screen. Second, install mesh screen on the facade building. Third, connect the mesh screen to the sub-control box, which contain AC 220V input power and access signal port. And lastly, the sub-control box connect to the computer to interact with the audience to display the image of the picture or the video on the facade building. AirLead 450 system is being used for LED facade lighting. The system utilizes the latest in ecological and energy-saving technology, underpinning our low-carbon era, providing control over energy costs opposed to older lighting systems. AirLead 450 system incorporates award-winning LED RGBAW UV lighting and receiving controller units utilizing PWM pulse width modulation for full color control and mapping each individual LED. Linked directly to BMS and DMX control system with fully integrated dedicated Wi-Fi and Internet controllers. The system offers both on and off-site programming capabilities, enabling multi-building sequencing of video type display. This system utilizes the latest in BMS system and promises a Rosetta Stone translating data input from users, building sensors, and so on. The AirLead 450 allows for a smart learning interface that can be merged to the building sensors and modify daylighting control, allowing for a facade lighting system with self-optimization.
Portal frame is considered rigid frames that consist of being supported by columns at either end in which the bending moment in the beam is transferred to the column. It acts as one structural unit where the frame is the major framing elements that support the roof structure. A proper attention and special care need to be given for the joints and connection between members, as the bending moment from the rafters will then be transferred to the columns. So if the connection is not proper, it will open up and the frame will be unstable upon contact with load. So portal frame structure was first developed during the World War II and only be made popular in the 1960s. And now it is one of the most common form of building enclosure, especially for long-span buildings such as warehouses, factories, and commercial buildings. So the development of portal frame is driven by the need to have a low-cost building envelope. So from the picture we can see Gallery Des Machines by Ferdinand Dutert. It is considered as one of the earliest portal frame structure which is located in Paris. Apart from that, the most popular materials for this structure is steel or steel reinforced precast concrete. In some other cases, timber are also being used for this structure. The first joint is the ridge joint. This joint needs to be strong as it supports the roof structure. Sometimes gusset plates are being used to enhance the strength of the joint. Apart from that, diagonal bracing is also needed to strengthen the framework. Through the usage of this bracing, it can prevent any unwanted movement of the framework. The next joint, which carries the same importance, is the knee joint. It is the connection of the beam to the column. It is important to maintain a strong joint or connection to prevent any forms of deflection under load as it supports the roof load. There are different types of portal frame structure. The first being the monopitch portal frame, which is usually being used for buildings which require smaller span. The second type is cellular beam portal frame. The rafters used are prefabricated cellular beams which have circular patterns along the beams. It is used not only for architectural purposes but also for the aesthetic of the building as it helps in providing long span building. The third type is mansard portal frame. It is used in a building which requires a large clear height at midspan, where the eaves height will then needs to be minimized. There are many advantages in using portal frame structure, with the first one being sustainable. It can be constructed quickly and rapidly, which in turn save time and costs. The framework are being done under controlled condition in the factory. Secondly is the great flexibility in terms of layout, as it is able to stand by itself through its rigid structure without depending on load-bearing walls. This also helps in creating more openings, which then promotes effective ventilation. It is also commonly used in agricultural buildings as it can provide long span aside from having the ability to be made watertight. Last but not least is providing large unobstructed floor space, which makes it suitable for buildings which require spacious floor space. Through this, water tanks with large surface area can be made.